Hello, and welcome to this Bitwise webinar on modernizing your legacy application to run on Pivotal Cloud Foundry natively. My name is Nathan Nichols, Communications Manager here at Bitwise, and joining me today is our very own Adrian Gonzalez. As a solution architect at Bitwise, Adrian plays a key role in helping clients modernize legacy applications on cloud platforms. With over 18 years of experience in the software industry, he brings a deep understanding of modernization efforts and building CI/CD automation systems. Before I pass things over to Adrian, let me first provide a quick introduction to Bitwise. Bitwise, a technology consulting and services company, uses over 23 years of enterprise data and digital experience to help bridge gaps between traditional tools and cutting-edge technologies, including big data and cloud. What truly sets Bitwise apart is our technology leadership in creating unique accelerators and frameworks that reduce the time, complexity, and cost of large-scale initiatives such as cloud migrations. Just a little note before we get started, we do have a Q&A plan for the end of the session. If you have any questions, you can send those via the question feature or contact us at any time at sales@bitwiseglobal.com. And with that, I'd like to pass things over to Adrian. Adrian?
Yeah. So, hi everyone. So, we have a lot to cover here in 30 minutes. So let's dive right in. In this webinar, we will briefly touch upon these following topics. First, we will look at why you want to modernize in the first place. Then we will look at what is modernization and what is involved in the process of modernization. We will then look at some of the challenges that you will come across modernization. And next, we will see some recommendations based on our experience. Then we will touch upon if PCF is the right solution for your cloud modernization efforts. And finally, we'll wrap with a short demo. Application modernization you will see in this webinar is a journey, and it's not going to do it justice to try and demo it in a short webinar. So instead, in this demo, we will just look at the benefits of modernization. So let's start. So why modernize? To understand why modernize, let's look at some of the pain points of a legacy app and see how modernization can help address these pain points. When dealing with a legacy app, you're generally dealing with an app that has a cumbersome UI. A UI that's assembled at the server side instead of a UI that leverages the power of modern computing at the end user device. You may also find that it's having an undesirable tight coupling between the UI and the app. So also in your legacy app, you will see that they're typically large and monolithic, and they have a high degree of complexity, and because of which they become inherently hard to change. And because these are large apps and they have a lot of resource requirements and dependencies, they are even hard to scale. So scaling becomes hard with the nature of the legacy applications. And because of the complexities in the applications, you end up with long testing cycles involving multiple teams just to make sure that you have tested thoroughly and you're not accidentally introducing any new regression in the app. And because of these long testing cycles, you end up with a limited release window and complex production installs that you have to coordinate with multiple teams that might be releasing on the same day. So all these make legacy or monolithic applications difficult to change. And since changes need to go through extensive testing cycle before they can be safely released into production. So on the other hand, if you had a modernized app, the UI elements you will see are built out separately from the app generally, and you use frameworks such as React, JS, or Angular, which leverage the computing power at the end user using modern JavaScript frameworks. A modernized app is also much smaller because it has been functionally broken down into microservices, and being small, they are also much easier to maintain. Being smaller, a modernized app is also much easier to change because all the functionality of the app exists within the bounded context of a clearly defined domain of the app. Also, being smaller makes it easier to write extensive test cases for automated testing every time the changes are introduced. Modernized apps also adhere to sound design principles, such as a 12-factor app, which makes them stateless and easier to scale. So that's another benefit of modernization. And in a modernized app, you will see that long testing cycles have been replaced by continuous automated testing. This is possible because in a truly modernized app, you will have hardened it with extensive tests that run in an automated fashion. And finally, all these allow production installs to become non-events. So whenever code is built on your main branch and it passes all your tests, it is potentially shippable to production, as long as you have the feature toggles for the features that you want to release. This way, you decouple installs from releases and install small changes into production frequently, and then release features in a controlled fashion when you are ready. So let's look at what is modernization. So now that you've looked at why it makes sense to modernize a legacy app, let's look at what modernization entails. At the heart of modern platform as a service offerings is container and container orchestration. And you will see that modernization essentially boils down to making apps which are containerized easily. And this can be achieved by adhering to good design principles, such as the 12-factor app. And one way to make sure you're adhering to good design principles is to use software stacks that adhere to these kind of cloud-native principles. Spring, and specifically Spring Boot, is one such software stack. Spring has been around in the industry from a very long time and is generally considered to be the replacement of J2EE. So it has matured over the years and it has been battle tested at probably thousands, if not more, installations across various industries. Also, there are various approaches to modernization. For example, you could lift and shift your application to a cloud environment, and you could start realizing some of the benefits by using infrastructure as a service. But to gain maximum benefit, you should modernize your app and make it cloud native. Next, let's look at some of the challenges in app modernization. When you start on your journey of modernization, you will come across various challenges, such as how do you not introduce regression during refactoring of your app? Or how do you decompose your app into microservices? How do you define application boundaries when you decompose your app into microservices? How do you avoid vendor lock-in when you want to consume useful services from any particular cloud platform? And when you automate the testing of your application, how do you address dependencies on other microservices? And also, how do you address dependencies on services that have not been modernized yet, such as legacy SOAP services? And how do you ensure quality and accountability during an automated release? So these are some of the challenges you will come across when you're trying to modernize applications. And there are some typical solutions for some of these, such as you can preemptively start backfilling unit test cases before you even start the refactoring of your app. And when you re-architect your application, you can do structural analysis on the application to identify functional seams. And then you can chip away parts of the application based on these functional seams into microservices. You can then make sure you use only open source libraries and frameworks when you modernize, specifically those which let you migrate between different vendors with least resistance. Frameworks such as Spring Boot and Spring Cloud make this easier. And you could use consumer-driven contracts to verify contracts between microservices. And you could use service virtualization for testing legacy interfaces during automated testing. And then finally, you could record all of this evidence that you gather during your testing so that you can preserve them for audit purposes. So those are some of the ways you could address these challenges that you come across. And finally, let's look at some recommendations. Um, so this is the process we advocate for our clients, and this comes from the experience we've gathered from working with different customers. The process is essentially a multi-phase approach where we go through multiple phases of modernization, starting with the preparation of the app, followed by actual modernization, and then a CI/CD enablement phase. This multi-step process also lends itself nicely to incremental modernization, which is the approach that we recommend for our clients. Though modernization could technically be done in a big bang approach, especially for smaller applications, incremental modernization is the recommended approach for large organizations, since it carries with it lesser risk, better payoffs in the long term, and is less disruptive to the business. So let's look at where Pivotal Cloud Foundry fits in. And let's look at some of the reasons you might want to consider it as your target platform for modernization. Take a look at some of these considerations. You want to reuse investments that you made in infrastructure and resources. Data security is important to you, and you want to not move some of your workload to a public cloud. So you may need an on-premise solution or even a hybrid cloud strategy. So you want to choose a cloud platform that can be trusted and it has proven its reliability in the industry. That could be another reason. And you want your development teams to focus on building great applications, and you do not want them to be concerned with the intricacies of containerization and container orchestration. You have a polyglot environment, and you run multiple languages in production today. Though you have a polyglot environment, you might still primarily be a Spring and Spring Boot ecosystem. And you want a platform that plays nicely with the Spring ecosystem. So if any of these are already priorities that you're considering in your decision-making process, then PCF could very well be a suitable choice for you. So now let's go on to a quick demo for a modernized app. So here in this demo, instead of looking at the entire process of modernization, which will not do it justice in a very short webinar like this, we will instead look at a somewhat modern app and see some of the benefits modernization can deliver. So this app is a highly simplified version of a shopping cart application, which has a React-based front-end UI, which is served from a static Nginx server. This UI talks to an API gateway, as you can see in the Edge services. This gateway is based on Netflix Zool, and this gateway in turn talks to a couple of other services, such as the cart service, which in turn returns the shopping cart items. And there's also a product service, which gives us the definition of products in the cart. For example, the description, price, etc. And we have a fallback service for the product service. So this is mainly to demonstrate how modernized apps can be built to be fault tolerant and resilient. And finally, we also have an external config server that stores externalized properties for some of these microservices. So in the interest of time, we have recorded this demo and edited it to show you the main highlights that we want to touch upon, and also make it fit within the time frame of this webinar. So let's get started with the demo. So this is the services that we just saw in the previous slide. We have the product service, the product fallback service, then we have the cart service as we talked about, and then we have a gateway service. So the product service returns the definition of the product as we see, and it gives us the price, description, etc. And all of this is consumed by the front-end UI, as you can see here. The UI is a React-based UI, so if you look at the source of this, you will not find any of the actual data that you're seeing on the screen. The UI is fetching the data from the API gateway. So next, now let's look at what happens when you introduce some disruption. So for this purpose, we're going to actually shut down the product service and the API gateway is configured such that it goes to the fallback service automatically. So if you now go to the product service via the API gateway, you will see that it's getting the data from the fallback service. And if you check the UI, you will see that it continues to work, but now with data from the fallback service, as you can see on the screen. So now let's just start the product service back up again. And since we're using modern software stacks like Netflix Zool, this will automatically switch back to the primary service without you having to do anything. So if you go back to the UI and try to refresh it, you're back to the primary service. Right, so next let's look at externalized configuration. So in this demo, we have the product service, which is actually driven off using some property files which are externally configurable. So the image version that is displayed for the product is now in a Git config server, and so we're going to change the image version from the A version to the B version. And we have a config server that listens for these changes to the Git repository, and once their changes are done, it will ask the apps to pick up the changes, and you see that the configuration changes are reflected immediately without you having to do anything. So this is far easier than how you drive configuration changes in a legacy app. So this is another benefit of using a modern software stack. Next, let's look at blue-green deployment. So for this purpose, what we're going to do is we're going to actually do a deployment without blue-green, and then see how that goes, and then we'll compare it with the blue-green deployment. So for this purpose, we're generating some artificial load using JMeter on the app. We're hitting the product service, and you'll see that there is some significant load on it. So we are going to introduce a code change here. We are going to actually change the product description, and we're going to hard code it to say demo code change instead of the data that we are going to get back from the database. And right here, we just change the product description. We build it, and we're going to push this app while the load is running on the app. And if you wait for it, you will see that it introduces a disruption to the app, and it becomes unavailable. But since we have the Zool gateway, which is configured to go to fallback, the app will continue to function. But this is actually a disruption to the app. So you do not want to do production deployments in such a fashion, because this can be highly disruptive, especially if you do frequent deployments. Once the app is installed, it will be back up. Yeah, the product service is back up. Right, so you come back to the primary service, and that's our code change right there. We have the demo code change that we made in the code. So the description has changed. So now for the next part of the demo, we'll actually do the same deployment, but using a blue-green strategy. So we will restart the load on the application. And we'll make the same code change, but this time we will say with blue-green. And we'll push this change. And we have configured a Jenkins instance that listens to GitHub, and it should trigger a build job when it notices the change. And you can see it's kicked off right here. And the build runs, and it will actually deploy this app as a green instance first, where you do the validations on the green instance. And the green instance actually is a parallel instance to your primary instance, so it does not disrupt your main application. Yeah, so it's at this point we're checking to see if it's ready to promote the app, which is green, to the blue instance. And for the interest of time, we'll not actually go and verify the app. We'll just go ahead and we'll promote it. And it will promote it using a blue-green strategy. So what that allows us to do is that, yeah, that's our code change. You can see it's gone live with blue-green. That there is not a single disruption. If you look at the error rate, it's 0%. So it install the app into production without a single transaction failing. So that's the power of Blue Green, and modern computing platforms like PCF lets you do this with ease. Next, let's look at another feature of the PCF platform, that is auto scaling. So for this purpose, you're going to turn on auto scaling for the product service, and doing that, the UI is as simple as just clicking a button. But in reality, you would want to do it through configuration files, but for the purpose of the demo, we'll just use it through the UI. This binds an autoscaler service to the app, and we'll configure this autoscaling service to say that we want a maximum of 4 instances and a minimum of 1 instance. And we are going to make the autoscaling based on CPU utilization. We can use other rules, but in this case, we'll use CPU utilizations for the purpose of this demo. So we are saying that if it is less than 30% scale down, if it's more than 70% scale up, and if it's anything in between, hold the number of instances. So we're going to generate some autoscaling load over here. And for the autoscaling load, we're going to use 30 threads, and this should generate a very high amount of load. And you can see the throughput is like 456 transactions per second at this point. And this should drive the CPU utilization way up, and it should cause a scaling event. So you'll see here that the CPU is at 97%, and within a minute it should scale up. Yeah, there you see it's now scaled up to 4 instances. And now if we stop the load within a minute or so, it will scale back down to 1 instance. So that's how, auto scaling works for you. Yeah, it's back down to 1 instance. So that was our demo. And now let's quickly look at some future perspectives for the PCF platform. So what does the future hold for the PCF platform? To wrap up, let's quickly look at some of the exciting features that might be making its way into the PCF platform in the near future. PCF is a fast evolving platform, and some of these features have already made their way into beta versions of the platform, such as rolling updates. Even blue-green deployments is getting better with native integration with popular continuous deployment tools such as Spinnaker. The entire routing layer is in for an overhaul with a move towards service mesh-based routing, which opens up new sets of possibilities, such as canary deployments. Canary deployments, which is a form of weighted routing using the service mesh. And there are others which are, coming up on the horizon, so do keep an eye out for those. And with that, I would like to conclude this webinar and thank you for your time. Hopefully this has been beneficial to you and helps you make up your mind on how you want to modernize your applications. And I think if we have time, we can open it up for some last minute questions. So Nathan, do we have any questions?
Great, thanks, Adrian. So yeah, we have some questions here that we'll try and work through quickly. But as you can see, we've just scratched the surface more or less. So you can always feel free to reach out to us directly at sales@bitwiseglobal.com. But for now, let's get through a couple of these questions. So Adrian, one question is, how will you know when you have finished modernizing your application?
Okay. Yeah, so that's an interesting question. So there are both technical and cultural aspects to modernization. So if you think you would be done with modernization as a one-time effort, I think that would be a mistake. So modernization, as we saw, is not a destination, more like a journey. So because today's modernized systems will someday become the legacy systems of tomorrow, when better and newer ways are invented for building apps. So an important part of modernization that we have seen is the cultural aspect, and by cultural I mean introducing an engineering mindset. So it's a mindset that always thinks about continuous improvement. Introducing such a cultural change, it can be difficult, but we have found extreme programming to be a useful tool in driving behavioral and cultural changes. So, with the right partners and right tools, you'll be well placed in the journey of modernization. Yep. Anything else?
Okay.
I hope that answers the question.
Yeah, I think just to keep moving through here, we can go to a couple more. The next question is, what do you mean by incremental modernization?
Okay. Yeah. So by incremental, we mean that we would not recommend to migrate a monolith in a big bang approach during your modernization efforts, because that inherently carries with it a lot of risk, and there are chances that lots of things could go wrong with that approach. So instead of that, we would recommend doing some kind of a structural analysis on your application, finding functional seams in your application along which you can divide the monolith. And once you've found functional seams that you can carve out pieces of the monolith which have their own kind of bounded context, which and then also from these pieces that you've identified, you can then find the ones that see the most frequency of changes, and then kind of pry those parts away into their own functional microservices. So do migrate the monolith part by part, and so this way you strangle the monolith by moving some of the application, moving some of the functionality away into separate functional microservices. And instead of doing this in a big bang approach. And this is the benefit we've seen, at most of our customers, that doing it in this way provides the maximum return on investment, and is probably the safest way of doing that, of doing your migration. Okay. I think so, that was about. Do you have something else?
Let's close out with one last question. I think it's a question that everyone always asks. How long does it take to modernize an app?
Okay, yeah, this is really a hard question to answer, because it depends really on many factors. One is obviously, the size of the application that you want to modernize. And another aspect that would influence how long it's going to take to modernize is where your starting point today is. Depends on how cloud ready your application already is, and how well it is already functionally decomposed into its own bounded context. So larger apps could be a longer journey depending on the size of the monolith, but really small applications, which are they could start seeing cloud native benefits when you start modernizing within 2 months of a modernization effort. But there's no one size fits all answer here. It really depends on the application. I hope that answers that.
Yeah, it's a tough question to answer, but I think that gives some guiding points. And with that, thank you, Adrian, for the session today. And I'd like to thank all of you joining and for taking time to join us with this session today. We look forward to talking to you soon. Again, feel free to reach out anytime at sales@bitwiseglobal.com or visit us at bitwiseglobal.com. Thank you.
Thanks, everyone.